So let's start this particular topic, which is called functional dependency. Functional dependency, as you can see, there is two parts, functional and dependency. Uh, but it is talking about dependency of the relation. A relation means a table in a relational algebra. Oh, sorry, a relational database management system. In the relational database management system, relation, if I'll say relation, it is nothing but a table. If I'll say relationship set, then there is a relationship between two tables. Okay. And in a table, you know the structure of the table, how a table look like. There should be the name of the table. There should be different column of the table, and inside the table there must be rows. One row is called one record. In one record, it is nothing but the actual data, right? And we are talking about that data only. So if we'll go to the functional dependency, so what do you understand by functional dependency? Now, as you can see here we are talking about dependencies. Dependencies means uh, one attribute of a table. Means if you have a table of a student, so we have many attributes, right? We have roll number, we have name, we have let's say the address of the student, we have the branch, we have the semester. So all those are attribute, right? So if one attribute in a table is dependent on another attribute of the table, that is called functional dependency. Okay. Now you must be asked like why they are dependent. So the answer is they are dependent based on some constraint, and that constraint is nothing but your prime attribute constraint or primary key constraint. So we have already learned about primary key, right? So what is a primary key? So primary key is nothing but an attribute which has the capacity to uniquely identify a row, right? It means that when I say that attribute value, so I'll pick only one particular row from the table. If I am talking about one value of the attribute and the answer is more than one row of the table, then that is not a primary key. So when we create a table, we'll define the primary key, and based on the primary key, we enter the values into the table. And we also can enter the table which is different to each other, right? So once if we have entered the value of roll number one, that roll number one will not be allowed after filling the value of roll number one. That is called constraint. Okay. So your table should be, or your relation uh, should be within the constraint. And if your table is within the constraint, then you can find the functional dependency. So it says that functional dependency are constant to the set of legal relations. Here, relations is nothing but the table, legal table, set of legal table. Legal table, the meaning of legal table is whenever we create a table, there should be the primary key. Okay. And without the primary key, you cannot visualize the table. So primary key is required for relational database management system. Primary key is very much required. Uh, Second, it says that it plays an important role in database design. So while designing the database, the functional dependency is very much important. What is the reason why the functional dependency is very much important? So for that, we have to learn what is functional dependency, how it is working, what are the different conditions for that. So that we'll see one by one. So the functional dependencies are constraints that are derived from the meaning and interrelationship of the data attributes. It says that the functional dependency is based on one table. How many table? One table only. We are talking about only one table. And in one table, I told you that there are many attributes. So in one table, there are many attributes. So what will happen? These attributes may dependent on one attribute may dependent on other attribute in one table. So that particular is called some restriction, some constraint. That is the constraint that we are talking about in relational in functional dependency. Now functional dependency can be denoted as X, then it is saying functionally determines Y. This arrow, we can call this arrow as a functionally determines X, functionally determine Y, right? Between two set of attribute X and Y. So if we have X as an attribute and Y is an attribute, either you can take one attribute or the set of attributes. So X may be one attribute or the set of attribute. Y is also one attribute or set of attribute. And if we are writing X, which is functionally determine Y, then it is nothing but this X and Y are the attribute set of attribute, and we can say that X functionally determine Y or X determine Y. Okay, or you can say Y is determined by X. That also you can say. So X determine Y or Y is determined by X. So X may also be called as determinant. So X is called determinant. Y we can say is X is determining Y. Okay. So these are the terms that we have to remember, that X functionally determine Y. So X is called determinant. Okay. To understand this particular slide, let's go and see this particular table. Now, if you'll see this particular table, you'll find it out. Let's say social security number. There is an employer name. There is a some person or the that employee number. Okay, there is a project number. Then there is a project name. Then there is a project location. Then there is a hour. Then there is a age. Okay? So these are one table. Now in this table, if we'll talk about what is the primary key. So let's forget the primary key for a while, because we don't know what is a primary key here, because I haven't created this particular table. This is the table, or this is the instance that I got. Now let's find out the functional dependency. Now, what is the meaning of functional dependency? The meaning of functional dependency is which particular attribute determine which attribute. It means that if we are talking about one attribute and as a determinant, it means that when the left hand side part, or when this particular part is going to change, this is also going to change. If this is the same, this will be the same. That is the meaning of X determine Y. Okay, and that is said by this particular sentence. So we'll talk about which determine what. So if we'll say SSN, which is social security number, can we say social security number determines employee name? So if we have social security number as 1, employee is Ram. Again, if there is a social security number 1, employee is Ram. Getting it? It means we can say that the left hand side part, this part, if we'll take it as a roll number, and this part, if we'll take it as a name, then this functional dependency holds. Roll number determines name. Can we say that? Roll number of a student determine name. So the left hand side part, which is a determinant part, will be the roll number, and the right hand side part, which is which is determined by this particular determinant is your name. So if we'll take that particular thing in mind, so if I'll say roll number one, that roll number one will stand up, right? If I'll say again at some after some time, if I'll say again roll number one, so that person only will stand up. It means that for a course of time, the value, the functional dependency is not going to change. So at one instance of time, social security number is one, the employee name is Ram, right? And at time T2, again we have social security number one, the employee name is Ram. At the same, can it is true for all the at all the values in the table? So yes, it is true. If I'll say social security number two, the name is Ravi. After some time, two is Ravi. Again, some time two is Ravi, right? Because we have only one instance of it, so that is also holds. So can we say this SSN determines e name? Yes, we can say that. So SSN determines, or SSN functionally determines e name. Okay, the next question. Can we say SSN determines project number? Can we say that? SSN determines project number. So if you'll see SSN, the value 1, if it is determining project A123, again, social security number 2, the project is the same, no problem, because one roll number may have, one roll number has another, has same name. Next roll number may also have same name. Now let's talk about this. If we have again social security number 1, here the project should not be changed. Here it should be A123. Then only we can say that SSN determines project number. So I think you are getting it. Now what I want to say is you can take left hand side part, which is the determinant part, as a roll number, and you take right hand side part as the name, and then you can compare it. Can we say project number determine project name? So project number is A123, name is security. Again at time T2, project number is 123 and the project name is security. Now here project name is B231. Here the project name is DBA. Again, project number is 231 and your project name is BDA or DBA. Again, project, so again, project 123 has came and the project name is security. So in that way, you can say that project number determine project name. So we find two functional dependency here. SSN determines E number and project number determine project name. Right? Can we say project number determine project name as well as project location? Is it true? So project name number is there 123 is security and database BBSR. Then again project number is 123 security and BBSR. Project number B231 DBA RKL and project B2 DBA RKL. Yes, we can say that project number determine project name as well as project location. So is it true for hours also? So as you can see, can we determine it? The hour. So hour could be determined. How it can be determined? See, here is 123, hour is 8, but here it is 123, hour is 5. So it is not at all true, right? Can we say age could be? Age can also be not possible to determine because age may be different for different person. But yes, we can say that one person has the same age, right? So if we are talking about Ram, so definitely it has 29 age. Again, if we'll talk about same person, so the age will be the same, right? So for person, it is true. So we can say that this SSN determine E number as well as age is possible. But can we say that SSN determine hours? No, it is not at all possible. Hours means how many hours a person has been given to this particular project. So this is how we can define the uh, functional dependency. Okay, so what are the functional dependency we have? SSN determines ename. SSN also can determine ename as well as age, because these two attributes are belonging to one person, right? Then project number can determine project name and the location where the project is and where the location is. All right. So this is how your dependency works. Reverse is possible. Can we say that ename determines SSN? So it is looking the same with this particular table, but actually when we talk about SSN and the ename, it may be like for my Aadhaar number, there will be one person only, that is Suraj Sharma. But can I say that other Aadhaar number may also have Suraj Sharma? Yes. So can Suraj Sharma determine Aadhaar number or Aadhaar number determine Suraj Sharma? So it will be Aadhaar number which determines Suraj Sharma. So because Aadhaar number is unique and Suraj Sharma may be the name of two or more person. So that's why it should be the your Aadhaar number or your roll number or your unique number will be in the determining part, and your non-unique number, non-unique type of attribute will be in the right side part of it. So here we'll talk about this SSN which determine ename. This project number can determine project name and the project location, right? Your SSN and the project number can define hours. It says SSN plus project number can determine project hour, means the social security number of a person and the project. We can define the hours that for one social security number and the project, these are the hour how much they have worked. So that also can be explored. So these are all different functional dependencies. Now here we have alternate definition of functional dependencies. R means a relation. Relation means a table. Okay. R, which is a relation, satisfy X determine Y if whenever two tuple in any instance of R have the same X value, they must also have the same Y value. It says that what it says that if you are talking about X determine Y, so if you have one instance of X, which is let's say the roll number, then we have the name, the same name. And at a particular time, let's say I got same roll number, I should have same name. So that is the meaning of this particular sentence. R satisfied X determine Y if each distinct X value correspond to a unique Y value in any R. In any R means in any part of R or in any instance of a relation in the whole relation. So that is also a definition for functional dependency. So these two are the proper definition of functional dependency. Now let's all of you find it out that what are the different functional dependency exist in this particular table. So can we say A determine Y? Let's find it out. A determine Y is possible or not. If let's say we have A1, let's say we will talk about A determine Y means A will be the roll number type and B will be the name type. So if A will be the roll number, so if we have A1 as a roll number, B1 is a name, it is okay. But again, if we have the roll number, there should be the same name, right? So A determine Y is not at all possible. Getting it? Are you getting it? What I'm saying? If we have a roll number A1, the name is B1. But again, a roll number A1 came. So here should be B1, right? Here is this different. So A determine Y is not possible. Can we say A determines C is possible? If we say A determines C means A is a roll number, C is the name. So A1 is a roll number, C1 is the name. Okay. Again, A1 came, again C1 is there, it is okay. Then we have A2 as a roll number and C2 is the name, it is okay. Again, A2 came, then C2 is the roll number. That's it, sorry, C2 is the name. And we have roll number as A3, but again C2 came. It is possible, right? So two-person may have the same name. So let's say one person is A3, have the same name, and A2 is also having the same name. It's possible. So can we say A determines C? Yes, we can say A determines C. Other possibility is say D determine B. D determine B. It is possible. Let's see. We'll take D as a roll number and B as a name. So D1, which is a roll number, B1, which is a name. Again, D1 is there? No. Let's talk about D2. D2 is the roll number. B2 is the name. Again, D2 came, yes. So B2 should be there. Getting it? Then there is a D3, only one instance. D4, only one instance. It is okay. So D determine B. Yeah, it is possible. It says AB determine D. A and B, you take it as a roll number and D as a name. So A1, B1, which is a roll number, determine D1. Okay. Can we have A1, B1 again? No. Then A2, B2 determine D2 is okay. Can we have A1, B2 again? No. So as you can see, you have the unique left-hand side part. So if you have always unique left-hand side part, there always be the right-hand side part will be the determinant. As you can say, all are unique, right? A1, B1. So there is no A1, B1. A1, B2, there is no A1, B2. A2, B2, there is no A2, B2 again. A2, B3, there is no A2, B3 again. So left hand side part is unique. So definitely right hand side will be the determinant. So if you will find it out any primary key, so definitely that primary key will be your determinant part.